Hey, this is Mr. James. In this video, we're going to do a quick review of the Pythagorean Theorem and add in some of the things we've learned about radicals and square roots at the same time. So first, the Pythagorean Theorem. The Pythagorean Theorem is useful for finding the length of the legs of a right triangle, and only a right triangle. It does not work for acute, obtuse, any of these other kinds of triangles, only right. And it's good if you know two of the lengths of a right triangle. You can use the Pythagorean Theorem to find the third leg. Now, the Pythagorean Theorem says that if you name the sides of the right triangle A, B, and C, where C is the longest leg of a right triangle, also known as the hypotenuse, then A squared plus B squared equals C squared. The length of A squared plus the length of B squared will equal the length of C, the hypotenuse, squared. And again, hypotenuse is the longest side. You can also think of it as always being across from that right angle, if you're not sure where the hypotenuse is. It's the opposite side to the right angle in a right triangle. So let's go ahead and apply the Pythagorean Theorem. Find the missing side of each triangle. Leave your answers in simplest radical form. Since I've got a right triangle here, two sides are known, the third side is unknown, I know I'm going to have to use Pythagorean Theorem. So let me just write out the theorem itself. A squared plus B squared equals C squared. And I like to label my sides too. A and B are the shorter legs, doesn't matter which one, but C, remember, is always the longest side, the hypotenuse, across from the right angle. So that's x. So let me go ahead and substitute my values. A 6 centimeters squared plus 8 centimeters squared equals x squared, that longest side, the hypotenuse. And we can go ahead and simplify this. 6 squared is 36 plus 8 squared is 64 equals x squared. I can combine these to make 100 equals x squared, and then at the end I need to get x by itself. So how do I undo or cancel out this square? Well, remember, the inverse of squaring is a square root. So I'll take the square root of both sides, and the square root and the square will cancel each other out, and I'm left with the square root of 100 for x, which is 10. So x is 10. What about number 2? Well, in number 2, let's see. Let's start off with our a squared plus b squared equals c squared, the Pythagorean theorem for right triangles. And there's a, there's b, and c, remember, across from the right angle. And this time, our x is not the hypotenuse, it's b, it's one of the legs. So let's substitute in our values. A is 5 squared plus x squared equals 13 squared. 5 squared is 25 plus x squared. I can't do anything with that yet. And 13 squared is 169. All right, so I need to isolate this x by itself. So we need to get this 25 out of the side of the equation. And if you remember how to solve equations, remember the best way to do that is subtracting 25 from both sides, so that we're left with x squared by itself on the left-hand side. And 169 minus 25 is 144. And then again, just like before, we need to isolate the x, get rid of that squared, so we take a square root. And fortunately, the square root of 144 is a nice number. That is 12. On to number 3. Number 3 is just like 1 and 2. We're going to use the Pythagorean theorem, but at the end, we're going to have a little bit of a twist. Our answer is not going to end as nicely as 10 or as 12. It's going to end up having some radicals, some square roots. Let's see how we deal with those. Again, Pythagorean theorem is a squared plus b squared equals c squared, where a and b are 8 and x, and my hypotenuse is 12. So we have 8 squared plus x squared equals 12 squared. 8 squared is 64 plus x squared, and 12 squared is 144. Just like in the last problem, number 2, I'm going to subtract 64 from both sides to get that x squared by itself. 144 minus 64 yields 80. And now I take a square root, okay, and so I have x by itself equals the square root of 80. Well, wait a second. This 80 is not a perfect square number. There is no square root of 80. That's a whole number. So we're going to have to simplify this, because the directions ask me to leave my answers in simplest radical form, which means I'm not going to put this in the calculator. I'm going to simplify this with the square root. So I asked myself, what divides 80? What perfect squares divide 80? And, well, 4 does, but 16 also does. 16 divides 80, and 16 is a perfect square. So I can write this as the square root of 16. And what's left over? Well, 16 times 5. And the square root of 16 is 4. The square root of 5, well, we're left under the square root. And so x equals 4 square root 5. Notice, again, simplest radical form. If it had said to give my answer as a decimal or to round to maybe 2 decimal places, I would have put the square root of 80 in my calculator. If I put the square root of 80 into my calculator, let's see what I would have gotten. The square root of 80 equals 8.944 and so on. So if it told me to round to 2 decimal places, maybe 8.994 would have been what I would have gone with. So x would have equaled 8.94. And so that's the approximate solution. And so to show that, I'm going to use kind of a squiggly equal sign right there to show that x is approximately equal to 8.94. Our fourth one here is even a little trickier, right? We've got the square root of 6, 2 square root of 3, and x. Well, we can still use the Pythagorean theorem, and we'll talk about what happens as we go. So again, a squared plus b squared equals c squared. A and b are those two. C is my x. So we're going to have the square root of 6 squared plus, I'm going to use parentheses for this so I get the whole thing, 2 square root 3 squared equals x squared. Now, you might remember from a previous video that when we square a square root, they cancel each other out. They're inverse operations. And so when we look here, the square root of 6 squared, well, the square root and the square cancel each other out, and we're left with just 6. What about this over here? 2 square root 3 squared. Well, when we square this whole number, both the 2 and the square root of 3 get that square. 2 squared is 4. And the square root of 3 squared, well, remember, those two things are inverse operations. They cancel each other out. We're left with just 3. And so 4 times 3 is 12. So the square root of 6 squared is 6. 2 square root of 3 squared is 12 equals x squared. 6 plus 12 leaves us with 18 equals x squared. Now we need x by itself. We take a square root of both sides. The square and the square cancel each other out just like before, and we're left with x equals, well, 18 again is not a perfect square. And so what are we going to do with this? Well, what perfect squares do divide 18? 9 does. We can break this down into the square root of 9 and the square root of 2. And so 9, square root of 9 becomes 3. The square root of 2, we have to leave that. And we're left with 3 square root of 2 as x. Again, if we wanted to, we could get an approximate answer with a decimal. We would just have to grab our calculator and type in 3 square root 2. So that's 3 times the square root of 2. And get 4.24. And so x is approximately equal to 4.24. Now you might say, Mr. James, wait a second. We had the square root of 18, and then we had the square root of 3 square root 2. Aren't those two different things, right? Square root of 18 and 3 square root of 2. Does it matter which one we put into our calculator? And the answer is no, because they actually are the exact same thing. Think about fractions. When you simplify fractions, you might have 4 over 2, which ends up being 2 over 1, which is the same as just 2. And so when we're simplifying square roots, the same thing happens. The square root of 18 is the same value as the square root of 9 times the square root of 2, which is the same value as 3 square root of 2. To show you, look at this. 3 square root of 2 came out to 4.24. What about the square root of 18? The square root of 18 also comes out to 4.24. So it doesn't matter at which point you put this into the calculator, if you need a decimal in the beginning or at the end. Both will work. In fact, a nice way to check to make sure that you've done the simplification correctly is to put the original square root of 18 in the calculator, get 4.24, and then put your final answer, 3 square root of 2 in the calculator, get 4.24, and since they're the same, we know that we've done our simplification correctly. This is the end of part 1 of the Pythagorean Theorem review. In part 2, we're going to do some more advanced problems, some challenge or tier 2 problems you might call them, but this is the end of this video. Hopefully you've learned a little bit from this, or at least reviewed. If you're confused, please come and see me before the next class, as we'll be taking a video check. Good luck!